In today's video, we are going to build a very simple VXLAN lab on Arista switches. But before we start, I want to show how useful netlab is on containerlab. I have already been working in this lab. I'm going to reset it and start over using netlab. From the lab directory, I'm going to type netlab down cleanup. This will reset the lab. Then I will type netlab up, and this will bring it right back with the initial configs. In about a minute, we will have 2 Arista switches and 2 Linux hosts ready to use. As you can see, netlab did all the initial configuration and brought up the lab. Now that the lab is up, let's look at what we are building. This is one of Ivan Pepelnjak's labs from ipSpace.net. The goal of the lab is to stretch VLAN 100 between 2 switches using VXLAN. We have host 1 connected to switch 1 in VLAN 100 and host 2 connected to switch 2 in also VLAN 100. Between switch 1 and switch 2, we have a routed underlay link, and it already comes configured with OSPF. So our job is to build the VXLAN overlay. VXLAN will take that layer 2 VLAN and carry it across the layer 3 network. At the end, VLAN 100 will map the VNI 100. Switch 1 and switch 2 will use their loopback 0 interfaces as VTEPs, and host 1 will be able to ping host 2. Before we configure VXLAN, we need to make sure the underlay works. In this lab, the underlay is already configured, but we still need to verify it before we build the overlay. First, we will check the OSPF neighbor on switch 1. We want the OSPF to be in full state, so we go to switch 1, type show IP OSPF neighbor. As you can see, the neighbor is in full state, so the routed underlay is working as intended. Next, we will test VTEP reachability from switch 1 to switch 2 by using pings. For this, we will ping 10.0.0.2 source 10.0.0.1. The ping is successful. That means switch 1 can reach the remote VTEP address. VXLAN depends on this IP reachability between VTEPs. If this ping failed, VXLAN would not work. Next, let's check what is already built for us. For this, we will look at VLANs by typing show VLAN. As you can see, VLAN 100 is already present on the switch. After this, we will check Ethernet 2, which is the host facing port. Show run section interface Ethernet 2. The interface is already configured as an access port in VLAN 100. Now we will check interface VLAN 100. Show run section interface VLAN 100. There is no IP address on VLAN 100 because we are not routing between VLANs. We are only stretching one layer 2 segment across routed underlay, so this is correct. Before building VXLAN, we need to make one underlay change. VXLAN adds extra headers, so a normal 1500 byte packet from a host becomes larger after the switch encapsulates it. If the underlay MTU is too small, small pings may work, but larger packets can fail. First, on switch 1, we will raise the MTU on Ethernet 1 to 1550. Ethernet 1 is the routed underlay link. For this, we'll go conft interface E1 MTU 1550. We'll do the same on switch 2. We'll SSH in conft interface E1 MTU 1550. Now this is done. We have enough MTU for VXLAN to work. The underlay can carry the larger VXLAN encapsulated packets. Now let's build the VXLAN interface on switch 1. In Arista, the VXLAN tunnel interface is called VXLAN 1. So we'll go to switch 1, conft, we'll type interface VXLAN 1. Next, we will set the VXLAN source interface to loopback 0. This will tell switch 1 to use loopback 0 as a local VTEP address. For this, we'll type VXLAN source interface loopback 0. Next, we will map local VLAN 100 to VNI 100. VNI stands for VXLAN network identifier. It is like the VXLAN version of a VLAN number. For this, we will type VXLAN VLAN 100 VNI 100. And lastly, since this is a static VXLAN lab, we will configure the BOM traffic, broadcast, unknown unicast, and multicast traffic for VLAN 100. For this, we'll type VXLAN VLAN 100 flood VTEP 10.0.0.2. This is it for switch 1. Now we will do the same thing on switch 2. Conft interface VXLAN 1 VXLAN source interface loopback 0 VXLAN VLAN 100 VNI 100 VXLAN VLAN 100 flood VTEP 10.0.0.1. Now the VXLAN configuration on switch 2 is complete as well. Next, we will verify the VXLAN pieces. For this, we will go back to switch 1. We'll type show VXLAN-VNI. We can see here that VLAN 100 is mapped to VNI 100. Next, we will check the remote VTEP. Show VXLAN VTEP. Each switch should have the other switch as a remote VTEP. We can see here switch 2 is remote VTEP. Then we will check the flood list. Show VXLAN flood VTEP. VLAN 100 has a static flood destination. This is the remote VTEP used for bomb traffic. Finally, for the control plane checks, we will look at VLAN memberships. If we type show VLAN, here we can see VXLAN as part of VLAN 100. This proves that local access port and the VXLAN interface are in the same layer 2 domain. Now we will test the actual connectivity from the containerlab host. Netlab connect to host 1, then ping host 2. Host 1 can ping host 2, so basic end-to-end VXLAN connectivity works. A normal ping is small, so we should also test the full-size packet. First, we will connect to host 1. Netlab connect host 1. Will ping host 2 with a 1472 bytes packets. This also works. This proves that the VXLAN encapsulation is not breaking normal 1500 byte host traffic. After the host communicate, we can check what the switches learned. On switch 1, we will check the VXLAN address table. This should show the MAC addresses learned from VXLAN from the remote VTEP. For this, we go back to switch 1. We type show VXLAN address table. Here we can see the MAC addresses. If we type show MAC address table, here we can see host 1 looks local and host 2 looks like it's reachable through VXLAN. So that is the full lab. We verified the routed underlay, increased the underlay MTU, created VXLAN 1 on both Arista switches, mapped VLAN 100 to VNI 100, configured static flood VTEPs, and tested host connectivity from host 1 to host 2. VXLAN lets us stretch layer 2 over layer 3, but the underlay has to work first and the VTEPs have to reach each other. Thanks for watching. See you next time.